Hello, I am Alchapar. Together with my colleague Claudia Pesuto, we are going to present the investigation called Reference Weather Data Selection in Urban Weather Generation Model. Urban simulation models play an important role in the design, analysis, and optimization of the shape and technology of cities in order to improve energy use and reduce the impact on the environment. However, due to the extreme complexity of the building environment and many interacting parameters, it is difficult to obtain an accurate representation of a city. The precision of the geometric input parameter of urban area and the selection of meteorological file directly determine the final result of the simulation. This research examines the capacity of urban weather generator model to estimate the air temperature and humidity inside urban canyon from measurement at rural weather station. For that, two types of rural climate file were assessed. The first file is the long-term weather, which contains a typical meteorological year, which is a set of 12 months calculated according to the ISO methodology, and the second file is the single year that is manually built with climatic data of a specific. This research was carried out under two climatic contexts, in the city of Mendoza, Argentina, and in the city of Campinas, Brazil. According to Köppen climate classification, Mendoza, Argentina corresponds to a desert climate with cold steppe, while Campinas, Brazil was a warm temperature climate with dry winter and hot summer. We selected suburban neighborhood area in Mendoza and other in Campinas. These areas are located in a region with low horizontal building density and residential zoning. For microclimatic monitoring, we place a sensor in the center of the study area. The input parameters of urban weather generator model are a file that describes the characteristics of the urban reference site and a file that contains rural weather data in Energy Plus format. In this research, a long weather term and a single year file were compared. The figure shows the curve of single-year file in dotted line and the long-term weather file in continuous line. Black lines and the air temperature data and gray line and the relative humidity data according to each city. The red arrow shows the wide differences obtained by contrasting both rural climate files such in Mendoza and Campinas. Therefore, these input data have a significant impact on the output result of the simulator. Now Claudia Pesuto will present the output result in contrast to the data of the fixed point.
In these sections, we compare the air temperature of urban sensors installed in the cities of Mendoza and Campinas with the values estimated by UWG model. Table shows the comparison between the values of air temperature and relative humidity at the fixed point here and the estimate point above the urban canopy layer here. This shows that the city of Mendoza is hotter and drier than the city of Campinas. When compared air temperature at the fixed point, values in the range of 24.8 and 37.9 were found in the city of Mendoza, and Campinas with values in the range of 18.9 and 32.7. The city of Mendonça showed relative humidity between 15% and 33.8%, and Campinas showed relative humidity between 35.3 and 91.1%. A better adjustment was observed for both air temperature and relative humidity when using the weather file single year. However, the UWG models tend to overestimate the temperature for the city of Mendonça and underestimate Campinas' temperature. The model presents a low performance in both cities when using the long-term weather file. When assessing the accuracy of model, the results show a good performance in air temperature for both cities. The coefficient of determination values of 0.96 in Mendonça and 0.98 in Campinas when using the weather file single year. Whereas if the simulation is performed with typical long-term weather data, the coefficient of determination is lower. These results show how the use of single-year weather file greatly reduces errors between observed and simulated data. The model presents a low performance in both cities when using the long-term weather file. Future work will analyze the specific data of solar radiation normal direct and diffuse. Thank you all for your time and attention.